Okay, so today we're going to talk about and learn how we factor. Sorry, don't know if you can hear me. Hopefully you can hear me now. All right, today we are going to learn how to factor trinomials. So we know that trinomials are always written in standard form. So if we have something like 3x squared minus 6x plus 11, there are these values a, b, and c that we should recognize. A is always going to be the coefficient of the squared value, so 3 in this case. B is always going to be the coefficient of x, and c is always going to be the constant. So it's important for us, not only in this section, but also when we learn the quadratic formula, to know what a, b, and c is. So let's take this first problem. And we want to check and make sure that it's not any of the special cases. Remember, the first special case was difference of squares. Is this two terms? Is it subtraction between those two terms? And are both of the terms perfect squares? Well, we know that this is not the difference of squares because, first of all, it doesn't have only two terms. The next special case that we learned was binomial square. Is it a binomial square? Does it have three terms? Yes, it does have three terms. Is the second sign positive? Ooh, yes, it is. Are the first and third perfect squares? No, 30 is not a perfect square. A squared is, but 30 is not. So we know that this is not, my answer is not a binomial square. So what we do now is we are going to use this method that I call A times C. So we go back, remember, A is going to be the coefficient of x squared, and C is going to be the constant. So what is my A value? What is the number in front of A squared? Well, there's an invisible 1 there. So A is equal to 1. What is C? C is going to be my constant, 30. And we're going to multiply A times C to get a number. And then I want the factors of that number. What are the factors of 30? The factors of 30 are 1 and 30, 2 and 15, 3 and 10, 4 and, no, 4 doesn't go into it. 5, yes, 5 and 6. And I don't have to go any further because what comes after 5 is 6, and we've already gone around the horn. Good. So we're going to look at this problem. And what do I know about my signs? Well, I know something about the signs of my binomials. I know that if this is a positive, the only way, because this is a product of two numbers, the only way you get a positive by multiplying things are if the signs are the same. Okay, if you have, remember, that third term is produced by multiplying the last of both of the binomials. So I know the signs are the same, and if the signs are the same, I can look here, and that is an indicator on what they are, that they're both negative. So I'm going to take those signs and I'm going to apply them to my factor pairs. Okay, so I have, well, let's move that over a little bit. Good, let's erase this. And now I'm going to combine those. Negative 1 and negative 30 is negative 31. Negative 2 and negative 15 is negative 17. Negative 3 and negative 10 is negative 13. Negative 5 and negative 6 is negative 11. So I want to look at those solutions and I want to find out which one is equal to my middle. Ah, there it is right there. That is equal to my middle term. So I'm going to take those two factor pairs, negative 5 and negative 6, and I'm going to turn this 3-term, this trinomial, into 4 terms. So I'm going to write a squared minus 5a minus 6a plus 30. How did I get negative 5a and negative 6a? I got them because of right here. This negative 5 and this negative 6. Negative 5 and negative 6. So we know that if we combine negative 5a and negative 6a, that we would get negative 11a. So I haven't changed this equation in any way. I just turned it from 3 terms to 4 terms. And the reason is I'm going to use factor by grouping. I'm going to group these first two, and I'm going to group these second two. And I'm going to take this group and I'm going to look for the GCF. So I look at a squared minus 5a. What is the greatest common factor from a squared minus 5a? Well, they both have an a. And if I divide a into a squared, that leaves me with a. And if I divide a into negative 5a, that leaves me with negative 5. Now I'm going to look at the second group, and I'm going to factor out the greatest common factor of that. One thing that I should recognize is that my first term is negative. So I need to find a greatest common factor of negative 6a plus 30, and I need to factor out a negative of that. So negative 6a plus 3, I can factor out a negative 6. So if I divide negative 6a by negative 6a, I get a. Divide 30 by negative 6, I get negative 5. And I know I did it correctly because these two parentheses are the same. That is the easiest indicator that you did it correct. So since these two products, this is a product here on the left and this is a product here on the right, since they both have an a minus 5 multiplying, I'm going to factor that out. I'm going to take this away, and what does that leave me with? That leaves me with a minus 6. So after I factor out an a minus 5, I'm left with a minus 6. So we can erase that. We can erase that. And we can erase that. All right, so when I factor this trinomial, a squared minus 11a plus 30, that is the two binomials that produced that trinomial. All right, a minus 5 times a minus 6 will give me a squared minus 11a. Let's try another one. So, is this the difference of squares? No. Doesn't have two terms. No, this has 3 terms. Is it a binomial square? Nope, because 20 is not a perfect square. Okay, so that means I need to do a times c. A would be 1, c would be 20. A is 1, c is 20. Remember, a is always going to be the coefficient of my squared term. 1 times 20 is 20. Factors of 20 are 1 and 20, 2 and 10, 3 no, 4 and 5, and I've gone around the hoop. Now I'm going to look at the signs. This tells me that the signs are going to be the same, and this one tells me that they're both positive. So I'm going to put those signs into my factor pairs. I get 21, I get 12, and I get 9. Okay, which one's equal to my middle term? This is my middle term. Which one's equal to it? Right there. So I'm going to use these two numbers to split the 9x up. So I'm going to write x squared plus 4x plus 5x plus 20. I'm going to group. I'm going to group the first two, and I'm going to group the second two. If I look at the first two, what's a common factor? X. If I factor it out, I get x plus 4. And I look at my second group. I'm going to factor out a 5. That leaves me with x plus 4. Did I do it correct? Yes, because these two are the same. So I know I did it. That's my visual indicator. So since they both have those in common, I'm going to pull that out, and you're left with x plus 5. That's a horrible 5. X plus 5. That would be my answer. Let's try another one. Let's try x squared plus, let's do 8x. 8x plus 4x. 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 Let's do 14x plus 24. So, not difference of squares, not binomial square. 24 is not a perfect square. So I'm going to do a times c. A is 1, c is 24. I get 24. Factors of 24 are 1 and 24. I have 2 and 12, 3 and 8, 4 and 6. Signs are the same. Both are positive. So plus, 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 plus. 25, 14, 11, 10. Which one's equal to my middle? 14 is equal to my middle. So I'm going to pull out those two values. So I get x squared plus 2x plus 12x plus 24. Let's group. I'm going to group the first and the second two. So I can factor out an x, that's x plus 2. Factor out a 12. If I take a 6, that's not the greatest common factor. I have to take out the GCF, which is 12. And if I took out a 6, let's take out a 6, I get 2x plus 4. I would know that I didn't do it right because those are not the same. They have to be the same. So I know that 6 is not my GCF. So 12 is my GCF, and that's x plus 2. Those are what's inside the parentheses are the same. And then that leaves me with, and that would be my answer. All right, last example. Let's use a different variable, b squared minus 5b plus, let's do 7. Okay, so not the difference squared, not the binomial square. Let's do a times c. A is 1, c is 7. Factors of 1 and 7 are 1 and 7. Signs are the same. Both are negative. So negative, negative. That gives me negative 8. This is not equal to my middle. Here's my middle, and that's not equal to it. So this cannot be simplified at this point. Or cannot be factored. Let's use that word. So we would leave it like this. We can't factor it at the time being, at the moment, but we will learn another technique later on down the road. Come and see me.